Today we're going to be looking at linked loci using my cat River as one of the parent phenotypes, as well as this orange spotted cat as the other parent phenotype. So the three linked traits that will be present in each of the parents is eye color, which green is dominant, brown is recessive, coat color, orange is dominant, and gray is recessive, and coat pattern, stripes is dominant, and spots is recessive. So in this example, we have my cat River, who has brown eyes, a gray coat, and stripes, and the locants that are present on his chromosome, and the internet cat that has green eyes, orange coat, and spots, and the locants that are present on his chromosomes. And when we do this cross, you can see that the traits are linked and they move together. And this parent generation would produce the F1 generation that looks a little something like this, where one part of the chromosome gets its linked loci from River, and one part of the chromosome gets its linked loci from the internet cat. For a visual representation of how this generation came to be, we can see River's chromosome here, and Mittens, which is what we're going to call the internet cat, its chromosomes here. If these two crossed, you could get a chromosome that looks something like this in the F1 generation, where this top part of the chromosome came from River and these linked loci, and then this bottom part of the chromosome came from Mittens with these linked loci. From this heterozygous chromosome, we can form this genetic map here, and in this genetic map we can see that there are three locants representing eye color, coat color, and coat pattern, and these are the distances in between, 15 centimeters and 11 centimeters in between these locants, and then the coefficient of confidence is 0.9 in this example. So using this genetic map and the information found in it, we can then predict the probability of different crossovers happening. So diving a little further into this double crossover calculation right here, you can see this double crossover in pink here. The probability would be calculated by doing the distance between locant 1 and locant 2, which is 15, the distance between locant 2 and locant 3, which is 11 centimeters, and then multiplying all of that by the coefficient of confidence. Now that would produce this number right here, which is the probability of all double crossovers, but what we want is the probability of just this double crossover, so what we would have to do to get that number is divide by 2, which would give us the 0.0074. Next, we're also going to look at the probability of this SC1 crossover at the first locant. This crossover is represented here with the yellow line where the crossover happens between locant 1 and locant 2. So in order to calculate that, you would take the distance between locant 1 and locant 2, which is 0.15, and you would subtract the probability of a double crossover, which is the 0.0149, and then you would divide that by 2 in order to get just this single crossover that we're focused on right here. And that would give you the 0.1351 probability. That concludes the lesson today on kitty cat crosses. Thanks for your time, and thanks for listening.